Today, we're going to be creating a top-down character in Godot using less than 100 lines of code. Obviously, you're not going to be able to create a full fleshed-out character with this, but this should be a great starting point for anybody who's interested in making a top-down game in Godot. So without further ado, let's get straight into things. When you open the editor for the very first time, you're going to be taken to this page. This is the project manager. Whether you open it the first time or this is your millionth time opening, this is your main hub to actually start your working on your game. So as you can see, I have my Pelago save right here, but today we're actually going to be creating our own. You always can import projects using the import, but today we'll press create. This will take us to our create new project window. Here, I can give the project a name, so I'll just call it top-down character demo. And we can also give it a project path. I'm just going to use the default path. Next, we have an option for our renderer. We have three main options. You have forward plus, mobile, and compatibility. Forward plus is used for if you're doing 3D graphics or at least very advanced 3D graphics, but it does have the downside of being available only on desktop platforms such as Steam. On the complete opposite end, you have compatibility. So this is less advanced 3D graphics, but it's available to a much wider array of platforms such as desktop, mobile, and web. Or there's also the middle option of mobile, which is middle ground for the graphics and supports both desktop and mobile platforms. Doesn't matter much what you choose. I use compatibility, but you can also change this later down the line as well. For our version control metadata, I recommend just keeping this as Git. You could select none, but Git is just great just in case you want to link your project to Git or GitHub later for version control. I think that's something amazing you should do if you haven't already started doing that, is learning how to use Git and GitHub. But even if you don't use it, just keep the metadata there in case you choose to use it later. Next, we can make sure Edit Now is selected and we can create our project. When your project opens, you'll be taken to the editor page, which can be a little daunting at first. But here's a quick rundown of the editor, which won't be completely exhaustive, but will be mostly enough to get you working in the editor, at least for now. In the middle area, you have the scene view, and this is where you can actually see the visible modifications to your scene. You can switch between 2D and 3D on this top bar here. We'll be using the 2D today. Next to these buttons, you have the script, which is where you'll actually be able to edit your scripts, and we'll see more of that later today. There's also the game bar, but this was also a part that will just pop out of your screen later when you actually run the game, so there's not much use for this. You also have the asset library where you can download assets, but again, we're not going to be using that today. On this left-hand side, you have the node tree. So this is where you're actually going to be able to stack all of your nodes within your project, which we'll talk a little bit more about what nodes are and how you can use them later. Down in the bottom left, you have the file system. So this is the actual file system that your project is using for your game. And this is exactly the same as it would be within your file explorer or whatever your operating system's equivalent to that is. You start off with a default icon SVG of the Godot symbol, and you can edit this is where you'll put any of your scripts, any of your scenes, anything like that. Even your PNGs for your players will be going in here. On the right hand side, you have the inspector, which when you have a node selected, will have a bunch of information about modifications you can make to it. You also have the node tab, which can be used to edit signals. And then finally, you have the bar at the very top where you can play your current scene or run the scene that you set as to be the default scene. All right, after that very basic tour of the editor, it's time that we actually create our first scene, which is going to be the player. So first we'll begin with actually importing any of your PNGs that you're going to be using for your player. I've already uploaded mine, and after this video is done, I'm actually going to create a GitHub with this project in it. So if you would like to use the sprites I'm using, feel free to give that a download and you can use these exact same sprites. But first, what we're going to do is we're going to create a new folder. So we're going to go to our file system, right click on the res folder, create new, and folder. And we're going to give it a name. I'm going to name this player. There we go. I'm gonna toss my sprites in there just because I want to make sure that everything is organized nicely. Now, if we look at the player file, the player folder, we can right click again, go to create new, and we're gonna create a new scene. Here we can create a bunch of different kind of scenes. What we're gonna want is to go here, and we're gonna want to search for a character body 2D scene. This is the scene that many of your characters, your NPCs, your enemies are going to use because it has collisions and it moves around really nicely. So we're going to use a character body 2D. We're going to give this scene a name. I'm going to name it Player because that feels like a pretty descriptive name to me. We'll see up here, we now have our player node up there. And down here, we have a player scene. So now that we have our player, let's actually add stuff to the player. I want to be able to see the player. So we're going to go over to our player and we're going to click this button up here to add a child node. Or you can use the shortcut, which is Control A, which will also bring up the panel. But yes, we're going to click that little plus button. And then we're going to go down to Node 2D. And we're going to look for a Sprite 2D. No, it's right around here. There it is. Sprite 2D and create. A Sprite 2D, what it's going to do is actually be able to let us see our player. So if we go over to the inspector and left click our Sprite 2D node, we're going to see texture. If we go down into our file system, we can grab our player sprites and throw them into the texture, which is actually going to let us see our player. Granted, it doesn't look great right now. So what we're actually going to do is turn off anti-aliasing. So we're going to go to project and then project settings. We're going to go down to textures. There we go. As you can see, it doesn't look great right now. So what we're going to do is we're going to open up our project settings. So project settings. And you're going to want to run all the way down to rendering and then textures. Once here, you're going to change your default texture filter from linear to nearest and close. You'll see that's going to make it real crisp because naturally the game doesn't want to actually use these tiny textures because they're so small, but we do want to use it since we're using pixel art for us. So this will fix it right up. But now that we have our player sprites in there, this doesn't look like one player, it looks like 16 players in a box. So to fix that, we're going to go over to this animation tab. We're going to still make sure our Sprite 2D is selected. Then go down to animation. And we're going to see our horizontal and vertical frames. So your texture might be different, but for me, I'm going to use 4x4 for this. 4 horizontal and 4 vertical. Because as you can see, we have 1, 2, 3, 4 spacing and 1, 2, 3, 4 spacing. So as I move this, you'll see it gets smaller and smaller. Now we can cycle through these animations by going from the frames, or we can go from frame coordinates, with the top left being 0 on both the X and the Y. All right, now that we got our player sprites working, next let's try to get them moving. So what we're going to do is we're going to go back up to our player and add another child node. Remember, you can either use Control A to make a child node, or you can come up here to go to create node. And this one, we're just going to want to make a node 2D. You can actually change the name of your nodes by just double clicking on them. You can change them. So I'm going to name this one the movement controller because this is going to be the node we use to move our player. To actually make the player move, we're going to be attaching a script. So if you have your node selected, you can come up here and press attach a new or existing script. And it's here that you're actually able to create the script. So you can name the path. I just want it within the player. So this default path is fine by me. And we're going to create, which will send us here. So the very first thing we're going to want to do is create a class name. I'm going to name this class name player movement controller. It's a good habit to get into early to class name most of your scripts, so that way you can actually type them. So that way it's easy to find them and you get auto fill if you're using referencing scripts in other scripts. All right, to actually start creating this script, we're gonna add a few variables. So specifically 3. So we want a variable to reference our player. So to create a variable, we're gonna write var, the name of the variable, and then we want a walking speed, so we're gonna go var walking speed. And finally an input variable, so var input. Now in Godot, this is perfectly fine. You could continue on from here like this, but for me, I like to type my variables, so that way I don't have any unexpected errors or unexpected functionality. So for our input, in order to type it, we're gonna put a colon, and then put the type. So this is gonna be of type vector2. The walking speed, I want to be an integer, so I'm gonna write int. You could also make this a float if you want more precise, but I found integers to be plenty fine. And the player, as we said earlier, is of type character body 2D. So I'm gonna write that as a character body 2D. These types that we see here can be of any built-in node or any class names that you have. So as you saw up here, we have our player movement controller. And so if I was in another script, like at the player script, I could say var movement controller is of type player movement controller, because you'll see it pop up. Obviously we don't need that right now because this is the movement controller, but that is something very cool that we can do. First, we're gonna want to write our ready function. So what a ready function does is this: when the scene is loaded for the first time, it's gonna call this function. So this is where you're gonna do any of your setup code or anything like that. For us, we want to get a reference to our player character, so the actual character body 2D. We're gonna do that by writing player is equal to get parent. So what this is going to do is it's going to say, hey, I'm the movement controller. This node is going to be equal to whatever my parent is. And as it can only have one parent at a time, its de facto choice is the player character body 2D. So that's going to actually let us mess with any of the functions within the player and mess around with where they are positioned. Next, we're going to write our process function. What a process function does is it runs once per frame for any of the things that you want to do repeatedly. So for us, we're going to be using this to figure out if the player is pressing any buttons, how they move, anything like that. So we have function, process, and then delta is just the amount of time that's passed since the last time it was called. I'm going to write an underscore there just because in Godot that's standard to write for anything that you don't use. If you don't use your delta inside your function, you underscore it. It's just syntax of what many people like to do. So I'm just upholding that here. So in order to get our input direction, let me just write a comment real quick. In order to write a comment, you're gonna put a little hashtag right in front, and then you can write whatever you want within there. So if you were to write code, like var player, it doesn't do anything because it is commented. So we're gonna get our input direction. So we can do input dot x is equal to the input dot get action strength. So what we're gonna do here is we're actually going to move away from the script for just a second. We're actually going to keybind all of our inputs. So if we go over to project settings, then we can go over to input map. Here we can add any buttons or anything like that that we want to use within our game. So for me, I want a button to walk up, button to walk down, button to walk left, and a button to walk right. So I know these 4 buttons are stuff I want. To actually add a keybind, you can go over here to the plus button, press add event. So for the up, in order to move up, I want to be able to press W. If you want to add a second one, you can press the plus button, and then the arrow button, and then press OK, and you'll get a second button. So now you're just going to want to do this for all of the buttons that you're going to be using, at least for your movement controller for now. And there we go. So now we have our up with WASD, or our up with W, our down with S, our left with A, and our right with D, and then the up, down, left, right arrows as well. So what this does is now that we can go back here using the input.getActionStrength, if we put up, this will tell us if up is pressed. So if we do that, if we get our up minus our get action strength down, that'll get us our movement in the Y. I'm just now realizing I put input.x. Let's make that input.y. Next, we're going to want to do the same exact thing for our x direction. So we're going to go input.get action strength east, or not east, left, right. No, yeah, right. Got confused there. Normally I use east and west whenever I'm coding for Pelago. Then we can do input dot get action strength for left. And just a little bit more, and then we'll be able to have our full movement script done. So what we're going to want to do next is we're going to do input is equal to input dot normalized. What this does is that it makes sure that your movement direction is constant and that you don't move extra when going around corners, because the normalized, it's going to make sure the vector is of certain length. This just kind of fixes any of the weird diagonal movement that you may have seen, where you move 40% faster by going in a diagonal. Next, what we're going to want to do is, now that we have our actual input, we're going to want to set it within this player. So what we're going to do is we're going to go player dot velocity. See, and that's why we typed our variable, is that way auto popped up. If I got rid of that character body 2D, we would have to go player dot velocity, and it doesn't actually show up with anything, so you can easily make mistakes there. But let's put that back. Now we got player velocity is equal to input direction, or we'll say input times the walking speed. And finally, we're going to do player dot move and slide, which will let our player move. And there we go. Believe it or not, that is all we need for a working player movement script. So, oh, actually, I take that back. One thing. We're going to want to change this walking speed to actually have a number attached with it. So we're going to want go var walking speed is an integer with a value of 50. So that way the player actually moves. Otherwise, we would be multiplying by 0 here, so we'd get 0 velocity. So now that we have the player scene, what we're going to want to do is we're going to want to create a level scene for our player to be inside of. So let's right click on the res folder again, create new, and folder. I'm going to name this scenes or levels. And then I can right click again, create new, and then scene, and just a 2D scene. So I'm going to name this level 1. I'm going to get rid of that scene and move this to the front, and we're going to go back over this 2D. Go back to this 2D, see if we're in the level scene. We don't see anything. In the player scene, we see our player. What we want to do is we want to get our player into our level scene. So we can do that by going back to our level scene, going into the file system, grabbing our player scene, and dragging that as a child. And now we'll see that our player is actually in the scene. So if we go up to the top right, click Run Project now, we're going to ask, hey, there's no main scene. Would you like to define one? So you can always change this later about what you want your main scene to be. So we'll just select current because we want our level scene. And we'll notice, hey, something's weird. We can't actually see our player. But in fact, we actually can. It's just way up there in that top corner. So we're going to go out real quick and we're going to add another node to this player. We're going to make this of type camera so that way we can actually see our player moving around. You can adjust the zoom to be whatever size you want. I like size 4. I think that looks really good, so that's what we'll do. We'll go back in. See the player's now in the middle of our screen. If we press our WASD keys, our player's moving. But we can't actually see it because the background is just pure gray, so it's not possible to see. So let's exit out a second time. Let's actually add a background so that way we can see it moving in reference to other stuff. So what we can do is we can go back to our level. We can create a new node of Sprite 2D. And I'm going to have this ground PNG that I imported as well with my players and put that into this texture. We'll see that it covers our player, but to fix that we can move this on top of our player, or we can also just go over here to ordering and lowering the Z index, that way it's below our player. And now if we run our scene, we'll see our player moves. I'm noticing I did make a mistake, so I swapped my up and down. So I'm going to go back to my player script real quick. We're going to say down minus the up. Now if I run it, now our player moves beautifully. And even though our player can move around, it's not necessarily the prettiest of things. So what we're actually going to start doing is we're going to start animating our player. So we're going to exit out of that scene real quick. And we're going to go back to our player scene. In here, I'm going to want to create a node 2D or a node. Either way will work. I just like using node 2Ds because I like seeing my entire scene view being filled with blue. Seeing the white/gray just kind of doesn't look pleasing to my eye, so I just use node 2D. And I'm going to name this our animation controller. As a child of this, we're going to add 2 nodes. We're going to make a animation player, and we're going to make an animation tree. So these 2 nodes are really cool and are the backbone within Godot in order to do a lot of animations. So we're going to go back to our 2D view so that way we can see our player nice and pretty. And we're going to press the animation player first. If we go to this bottom section, we're going to see animation. If we click this, we can create a new animation and name it whatever you want. I'm going to name this the idle down because they're facing downwards. You can name it whatever you'd like as long as you're descriptive. So now that we have this, this is our animation track. Here we're able to add any properties, if we want to call any functions, anything advanced like that we can do here. But it can also be as simple as adding our player animations here. So we're going to go from player animation player up to this Sprite 2D. And if you're noticing closely, you might notice that these keys have now appeared. These keys are the key part, funnily enough, for creating animations. And they're what we call keyframes. So if we take a look at these keys, we can press this key over here next to frame chords and click create, and that'll create our first animation of our player. It doesn't look like anything fancy yet because it's just playing the same animation we already have. But if we create a new animation like idle up, we can bump up this frame coordinate and we'll see they flip around. If we create another one, they now go up. And we have down, then we have up. So what we're going to want to do is we're going to want to repeat that process for both the left and the right animations. And now that we have those done, let's create our animations for the walking state. So we're going to go to the same process of animation, new. I'm going to call this walk down. Now let's go back up to the very top to our very first animations. So here, now if we click this keyframe multiple times, we'll notice that if we play it, our player kind of makes a quick animation. And if we zoom in, we'll see all of these keyframes. So these are the keyframes of what's happening. So as we move it, we can see that we change there and change here and then change again. So you can either move these to be at the places you want, or the way I prefer doing it is let's just get rid of all of these and zoom back out a little bit, is we can change our nearest FPS. So this will be the change between each frame default. So I know I want my timer to be 1 second long. So I'm going to put that at 0.25 seconds between each frame. So now if we click it, we'll notice that our player gets spaced out nice and prettily. Although we might notice, oh, I don't know what, oh, I was on the wrong animations. 1 second. All right, let's just redo this. This would be good to see it a second time anyways. So I'm deleting those, making sure I'm on frame 0, 0, and then keyframing. There we go. Now our player looks pretty. For a walk, what we're gonna wanna do is we're gonna want this to loop. So if we press here, now our animation is gonna keep looping. So perfect. Now let's repeat that process for both the walk up, the walk left, and the walk rights. And with that, we now have our animations working. But these are just a bunch of individual animations. What we're going to want to do is we're going to want to put these together so that way we can actually use them nice and easily in our game. And that's what our animation tree is for. So if we switch from our animation player node to our animation tree node, we can change what the tree root is. So first, actually, we're going to assign our animation player. We're going to just do our same animation player we've been using. And then we'll go to tree root, and we're going to make a new state machine. These are a bunch of different animation types that you can do, and they're all very useful in their own ways. But today, the state machine is going to be our friend. And we'll see a new tab pops down here at the bottom for animation tree. What we're going to want to do is come into this area and right click and add a new blend space 2D. What this is going to be able to do is, depending on the inputs that we use earlier for whatever way we're wanting to go, whether that's left, right, up, or down, this is going to change what animation plays. So we can left click and name it whatever we like. I'll name this idle. And then we're going to want to just press this play button right here so that way it's already done. Then click the edit idle in order to go in. Within here, this is actually going to be the space where you'll animate, or at least place your animations within. So I know we want to have our animations play. So our, oh, here we go. There we go. Create points. If we go over to create points, and then we can left click, then we can add an animation. We're going to put our idle down at the very top. That's a weird thing to note about Godot, is that they think positive is for the Y. They flip where positive and negative should be. So on a normal graph, you have positive is going up, negative is going down. But for Godot, negative is going up and positive is going down. So you just have to remember to switch up and down every time you use it. It's kind of a weird thing, but you get used to it after a while. So we put up or down at the top. Let's put up at the bottom. Let's put right on the right. and left on the left. So now we can move our character around. I'm going to see that the character actually moves around all fun and nice. Kind of goes a little weird. So we're going to switch this from continuous to discrete. Continuous is just used when you're using 3D models, mostly. So since this is a 2D game, we don't need that. And now we can look around. Oh, I'm noticing I messed up my animation player for my walk, or my idles right, and my idle left. So I am going to switch those real quick. There we go. Idle right and idle left. There we go. And now if I go back to the animation tree, click into there, and we can now move around, and we'll see our player follows our mouse. So to help describe this a little bit better, if we were to click just the up key for this, our vector 2 would point to 1, 0. So we would go from the center point down here, which means this animation would play. If we were to click the S key, we would instead be at -1, 0. So we would go up here. The right key would be 0, 1. So we'd go over here. Left key would be 0, -1. If you press two keys at the same time, like let's say you press 1, 1, you'll be down here. So it might play the down, it might play the right. You could also add another point here, so that way it determines exactly which key will be played. So if you say you want to go down always, if you're pressing S, then you can put an animation frame there as well. That's something we don't need to do for today though. Now, we're going to repeat this exact same process for the walk animation. So again, right click, go to Blend Space 2D, we'll name this walk. Press the play button, we can edit, switch from continuous to discrete, switch over to the pencil. Now we can add an animation, we can walk down because they're switched, we can walk up, we can walk right, and we can walk left. And now we'll see that our player's walking direction changes. Perfect. But now that we have those animations set up, it's time to actually incorporate them in the code so the player animates with whatever direction you're facing. So we're going to click our animation controller node, and we're going to add a new script. This one I'm going to just call our animation controller and have it within our player folder and create. As you may remember, we're going to add class names to most everything. So I'm going to class name this player animation controller. All right. So for this script, we're going to want three variables. The first is going to be an animation tree. So we want a reference to our animation tree. The second, so we want a reference to our player. Just like the movement controller, we want a reference to the player. And we want a last facing direction. Because when we stop moving, we want to idle in the correct direction. So I'm going to make this of type vector 2. And I'm going to just default this to a vector 2 value of 0, 1. Just that way we default to face down. We know our player is going to be of type character body 2D. The animation tree of type animation tree. So Godot has a really cool function called the onReady function. So if you add onReady to the beginning of your variable declaration, you can now declare it early. So we know we want our reference to our animation tree right here. So what we can do is we can go animation tree and pull it over. And as long as you don't change this name here, this will connect to that animation tree. If you were to name this tree animation, you could then call this tree animation and it would follow it. So it's just kind of the file path relative to where it currently is. So just like the movement controller, I'm gonna write a ready function. We're gonna name this, or have not named this, but player is equal to the get parent. Because again, this is the animation controller. We want the player reference, which is the direct parent, so we can just write get parent. All right. Next, we're gonna use our process function again. So let's create that. And what we're gonna wanna do is set our animation trees. So if we do animation tree dot set, we can actually go back to our animation tree, and under parameters here, we can open up idle and walk. If you're to change these parameters, it would change which position is currently playing within that 2D thing we were moving just a second ago inside the animation tree. So we want a reference to this, so we can pull this idle over and put it there. And we want our last facing direction to be the second argument. Now we can do the same exact thing for our walk. So animation tree.set, walk blend position, place that in, comma, and then last facing direction. And this sets the blend spaces in animation tree. It's a good idea to comment your code whenever you can, just to make sure you don't get confused later on. One last thing we need to do in this function is that we want to set the last facing direction. So we're going to check if player.velocity. So this checks saying, hey, is the player moving? And if the player is moving, we want to change their last facing direction is equal to player velocity dot normalized. So what this will do is if the player isn't moving, last facing direction is going to stay constant. While they are moving, the direction is going to be continuously changing, so we're going to be able to change which direction we're facing. And then when we stop, we won't change it anymore, and we'll keep with the same position we're doing. So now, if we go over and play our script, we're going to notice our player doesn't move. I think I'm missing a step here. 1 second. Yes. I actually ended up forgetting one of the most important parts of this entire process is actually the state machine. So today we're going to actually be writing a very simple state machine just to handle between our idle and our walking states. So currently we're setting the positions for all of these, but we're not actually animating. So that's a very important distinction. So what we're going to do is we're going to come up here to our player. We're going to add a new script. This one we're going to name player. And let's class name it. And you guessed it, we're going to class name as player. So for this one, we're going to want quite a few different scripts, or not scripts, variables. The first is that we're going to want a variable for our animation tree. So our animation tree, one for our movement controller, and one for our animation player. So if you remember, we can just type this to animation tree, and then we can go over to our animation tree and pull it in. So we'll see it says $animation controller / animation tree. And we'll see, yes, the child is animation controller, and then the grandchild is animation tree. We can do the same with our movement controller. So we can actually type this as player movement controller is equal to $movement controller. The animation player, type player not animation controller. Animation player. There we go. Sorry. Is equal to $animation controller / animation player. So you'll see some errors here, and that's because we need to add the on ready at the very beginning of the variable. There we go. So now we just need 2 more variables, and these can be a little weird. So follow for just a second. We're gonna make an enum. We're gonna call it state, curly brackets, and inside we're gonna put idle and walk. Next, we're gonna make a variable, type current, state, set that as state. So what these are gonna do is this is gonna control what state we're currently in. So this is the list of states that there are, and this lists what the current state is. So if I wanted to, I could have an idle, a walk, a run, fly, a die, etc., etc. But today we only need the walk and the idle, so I'll just keep it those 2. Alright. What we can do now is we can write our ready function. And what we're gonna wanna do in here is we want to set the state, set state as state.idle. It's gonna be the very first thing we wanna do. But you're gonna say, hey, there's no function for set state. We haven't written that yet. So we're gonna go over here. I write function set state date, and then it's gonna take a type of, we're gonna put new state, type state, and then it's not gonna return anything, so we're gonna just name that void. So for the current, for the set state, we're gonna have a few lines here. First is gonna check to see if the current state is equal to the new state. And if it is, then we just don't want to do anything and we'll return out of this. Because if I'm already idling, I don't need to idle again. There's no point in changing from idle to idle. So once we make sure that we are actually changing states, we're gonna exit state, exit our current state. We're gonna set our current state to equal new state. And then we're going to current state, and then we're gonna enter state. So we need to find these 2 functions. Do function exit state, type void, and just pass that for now. And function exit underscroll exit state type void, and we'll just pass that for now as well. Oh, my bad, that's enter state, not exit state. So whenever we exit the state, we want to do just a quick match the current state, and if it's state.idle, then we want to pass. If it's state dot walk, we want to pass. So this does actually nothing in our current setup, but if you were to have a more advanced system, maybe when you exit the state, you want a certain thing to happen. This is where you can actually make that happen, is with this exit state function. So it's a very cool thing that you can use, but for us, it's not going to be very useful. So I just wanted to let you guys know that that is something you can do. But this enter state, however, will be very useful. So we're going to do another match statement. So match the current state. And if it's state.idle, now we want to do our animation tree.travel to idle. And if it's state.walk, there we go. Oh, there we go. We're gonna do animation tree.travel to walk. did notice one mistake up here real quick, is that once we get this path with the animation tree, we do want to write .get, and then it's parameters / playback. This is going to actually allow us to travel between the nodes, otherwise it's going to give us an error. So the very last thing that we need to do is write our process function. So this isn't the best way to write this, but we're going to write a simple state checker just to see if we need to change states. So we're going to check, say, hey, if the velocity does not equal vector 2.0, so essentially, hey, if we are moving and our current state is not the walk state, then I want you to set your state as state.walk. So, oh, I'm getting an error here. 1 second. Where's? Oh, all right. There we go. So make sure we add the colon right afterwards. And then we'll set the state as state.walk. So we're going to do a very similar thing to set the state for idle. So if the velocity is equal to vector 2.0, so if we aren't moving and the current state is not equal to state.walk, then we will set the state to state.idle. And there we go. Now, if we go over and play our game, we are going to get an error. So we're going to say trying to assign type of animation node state machine to variables type animation tree. Oh yes, because this is kind of a weird animation state machine stuff, we can't really type it, so we will get rid of that type right there. And now if we play it, we'll see that our player is animated. We now have our player moving around and animating and all of that fun stuff. So obviously there's so much more you can do with this. You could add collisions, you could add tile maps to this, that way the ground looks a little bit better than a flat sprite. But there's a lot you can do from here, but this is a very good place to start off with and a very nice area to build upon. So if you enjoyed, please feel free to like or comment or whatever you would like. It really does mean a lot to me, and I hope you all enjoyed. I will see you guys next time. Bye-bye!